recording. Okay, so let's now do an example with the CEO compensation data on how we would calculate the variance, standard deviation, and range, and also coefficient of variation. So let me just go to, again, our CEO compensation, which gives us the salaries of CEOs and also the return in the year 2001. So let's do it. In order to calculate variance and standard deviation, we need the mean first, obviously. So just to make life a bit easier, let me name this range. Okay, and I have here 194 values. Okay, so let me name this as COMP. Okay, so now I have this name in the name box. So what would I need? I would need the average value, and I'll get it, or I could have specified B2 to be 195. Okay, so the average value is 19.8. So now I want to take, in order to calculate standard deviation or variance, I need to take the difference of this value, okay, from the mean. Okay, so when I do this, for each observation, I have either a value less than the mean or greater than the mean. Okay, and so let's continue to paste that. Okay, so you see some of these. So this is wrong, and it's a good thing that we did it, because we are not getting the correct values now. We should have used absolute referencing for E1. So let's use that. Put a $sign to the left and to the right of the letter. Okay, and you fix that. Now, so this is something I noticed, because while I was pasting down, some of the numbers were not reasonable. So this is the correct value now. So below the mean, it's a minus. Above the mean, okay, it's a plus. So I have all these differences now, xi minus x bar. So what I need to do is then to square it and then get the sum. So I could use actually a function which gives me sum of the squares, sum squares. Okay, and I can basically specify E2 to E195. Okay, let's just see if that's correct. That's correct, obviously. So when we do that, use the sum_q function, we take the sum of the squares of the differences from the mean. So just an additional step we have here is to divide this by n-1, which is 193, and then we get a value for the sample variance. Okay, now if you take the square root of that, the value I just calculated here, so I get the sample standard deviation. Okay, but again, I could have actually obtained these very easily by using two functions. Let me demonstrate them to you. When you start typing var, okay, and you get .p and .s, the one that I used is s. So, and if I say comp again, I get the same value. And if I use standard deviation and I choose s and say comp, again, I get 28. So if you want the population values, then you would have specified p for here, and you would get values slightly lower, a bit lower than the values we obtained here, okay? So just to demonstrate how sensitive this is to outliers, I will just delete this one, row number 22, and we can see actually how the mean is changing and how the variability is changing. So when I do that, okay, so you see the mean actually is decreased and the variability is largely decreased. So I'll undo it and you can see back what those values are. And the other thing I mentioned was the coefficient of variation, which can be found by dividing standard deviation by the mean, which is in this case 1.45 or 145%. And the other thing, again, we mentioned was the variability in terms of the range, and we can find the range simply by getting the maximum of comp, subtracting it from the minimum of comp. Again, the range 376, variance, sample population variance formula and population standard deviation formula. And we have here also the coefficient of variation. So we took individual differences, take the sum of squares, and we are able to find these measures of variability. So let's stop this right now.